So let's start, and we'll actually bring up that last one we were working on last day. First, it's so last day, we said, okay, we have example 147. I'll just copy it all from here. You have it in your notes, presumably. So, no biggie. Yeah. Okay. Change this. This is 114. You guys are my 006s. So just, oops. Oh. From last day. We started working on this, and then I said, go and finish this off, and then we'll finish it together on Wednesday. And here we are, you all finished it. But just in case, we'll do it together. Okay. So we said, okay, to finish drawing our timeline here, remember Okie Dokie Finance Company advanced 3 loans to D, so we drew our timeline, right? So we had 3 loans of different amounts on these 3 dates, and then she has to pay it all off December 31st, or New Year's, where all of these have some amount owing, right? So we need to first calculate the time for each of these lines, right, or these arrows, and then we can calculate the future values, and then we can add those all up to find how much she has to pay in total on New Year's Eve. That's rough. Okay. So we use the days between dates function to figure out the number of days between October 31st and December 31st. Okay. There's 61 days. So now, to find T2, same thing. Date 1 in the format month, month, dot, day, day, year, year, okay, is going to be August 5th. Right, so August is 08, the 5th is 05, and I don't think we're given a year, so we just use 2018. Okay. Date 2 is going to be the same for all of these, right? December 31st. So once you've entered it in your calculator, you can just leave it there. You don't have to change it every time. Okay. So 12.3118. And then we want to find the days between dates, and to indicate that I'm calculating it, I'm going to put a little star by the days between dates. Okay. All right, here we go. Second date function is on the 1. My first date is 08.0518. Remember to hit enter, right? So it stores it. It'll show it's stored because it changes the format. Right? Yeah. The question we didn't finish last day, example 147. Yeah. So you missed last day. Just jumping in. So date 1 is in, date 2 is still December 31st, 2018, so that's good. So we can scroll down to the days between dates and hit compute, right? The CPT is compute. So I get 148. So I can plug that in here. So T2 must be 148 divided by 365, right? Because T has to be in years, right? So 148 days out of 365. Same thing for T3. Date 1 is the only thing that's changing, really. June 23rd. So that's got to be 06.2318. Date 2 is still 12.3118. And we want to find the days between these dates. So I'm still in the date menu, right? So I can just scroll up, change my first date, go back down and compute the days between dates. Right? So my first date now is 06.2318. Enter. Okay. Scroll down, date 2 is fine. Days between dates, compute 191 days. So 191 divided by 365. This is our complete timeline. Okay. Remember, your timeline out of 10 is worth 4 marks. Kind of a big money maker. Right, so you want to make sure that you've got all the components. Okay, so now we can calculate each of these future values. Right? So future value 1 is, and we have our formula sheet, right? The future value is the principal amount times 1 plus RT. The principal amount for future value 1 is 1,300 times 1 plus the rate for all of these, right? What's nice is the rate is the same for all of them. That's not necessarily the case always, right? Is 0.0725 times the time, which we said was 61 out of 365. So bed mass is still a thing. So we have to do 61 divided by 365 times 0.0725. I'll just stop and show my work here. 1,300 times 1 plus, I'll skip straight to it, 0.012116438. Plus 1. I'm going to skip this step where I write out 1,300 times 1.012, blah, blah, blah. Right? And just go straight to times 1,300, 1315 point, and just rounding to 2 decimal places right away because we know we're talking about money. Right. Nice. So that's the first future value she has to pay off. Okay, how about the next one, the future value 2? Future value is still P times 1 plus RT. P for future value 2 is 1,800. The number of days was 148. I said it and then I forget it. Said it and forget it. 1,800 times 1 plus, what's that even from? Set it and forget it? Is it a slow cooker? Oh, it's definitely a commercial. But I feel like, I don't know if it is a slow cooker. No, I don't think there's something like that. Yeah, it's set it and forget it. Anyways, someone Google it, please. It's important. No, I can't remember, but I do remember the commercial, I guess. Does that make them successful or unsuccessful if I can remember their slogan, but not the product? Great slogan. I'll keep calculating while someone figures that out. A rotisserie. Nice. Set it and forget it. But not for too long, hopefully. It should have been a slow cooker. So 148 divided by 365. And then times 0.0725. Get that out of the way. Heck, why not jump straight to the big guns? 1800 times 1.02939726. Getting a little impatient as we go along. We have a lot of these to do. So times 1800. Oh, I think I only did 180. Rats. 148 divided by 365. So I start over, 0.0725 plus 1 times 1800. There we go. $18,052.92. Future value 3, same deal. Tedious, but to be quite honest, I like tedious. It means that we know what we're doing. And it feels good. At least when it comes to math stuff. Tedious is nice. 2,200 for 191 days. 2,200 times 1 plus the rate is still 0.0725 times 191 out of 365 days. 191 divided by 365 times 0.0725 plus 1. Jot that down, 2,200 times 1.037938356 times 2,200, $2,283.46. The total owing we said was future value 1 plus future value 2 plus future value 3. Okay. Home stretch here. We can add these all up. Future value 1 was $1315.75. Future value 2, $1852.92. Future value 3, $2283.46. Oof. 15.75 plus 18. Oops. Mucked it up on the second one. 1315.75. 1852.92 plus 2283.46. 545213. For adding up the future values, we're going to use the rounded values just because the future values are dollar amounts, right? And so I wouldn't dock marks if you kept all those decimal places. I encourage it. But I mean, technically, we should just round it to 2 decimal places then. But I encourage you keeping all your decimal places, so I won't take marks. But technically, now we round them as we use them. Confusing. So, total owing New Year's Eve is $5,452.13. She must pay $5,452.13 on December 31st. Bless you. Bless you, bless you. right? Which she borrowed how much? She borrowed 2,200 plus 1,800 plus 1,300. So she only borrowed $5,300, right? But she has to pay, right? So I'll just make a note here because this is why it's important. Borrowed $5,300, but then she has to pay $5,452.13. Could be worse, right? But that's just the time value of money, right? And I think you were using your calculator to do it before, I think, when you got that slightly different answer.
So just try to round the first value.
And the calculator doesn't do simple interest. That's why. Okay, cool. Woo. How's that feel? Good, long? Okay, I'll take it. That's fine. Okay, so what if we had to solve for R, right? So we said this formula, the future value is P times 1 plus RT, right? We can solve for any one of these four things as long as we have a third. So if we're solving for R, the future value is P times 1 plus RT. So you read a question and you realize, oh, I don't know the rate and it's asking for the interest rate, right? So then you have to solve for R. You have two options, right? You could just use this base formula that I like to do and just plug stuff in and solve for it later. But if you see that you have to solve for R a bunch of times over, right? It might be easier to just solve for R in general and then plug stuff in, right? And so from here, how would we solve for R? We have to divide both sides by P, so we get future value over P is 1 plus RT, right? We don't need those brackets anymore because we're just adding in there. Right? Nothing's being multiplied by those brackets. So then to get R on its own, we have to subtract 1 from both sides, so we get the future value over P minus 1 is RT. And then to get R on its own, we have to divide both sides by T. My signature move, I'll move the R over here, but everything here stays the same. The future value over P minus 1 divided by T. So now if you had to solve for R a bunch of times over, right, you don't have to do this calculation a bunch of times over. You can just do it once in general and then use that formula instead. Exactly. And we'll do an example. Yeah. So, or, right, on your formula sheet, from I equals PRT and the future value, right, you have R in both of these. So depending on what information you have, right, if you have the amount of the interest and the principal and the time, right, then it's easier to solve for R, right, because then you can just say, well, then R must be I over PT, right? Or from I equals PRT, right, we know R is I divided by P times T. Are these the same? No. So these are the same. So it just depends on what information you have. And I have in my notes, I have showing you how and why they're the same, but we'll just take it at face value because we've got a lot of stuff. Okay? And it doesn't really matter. It's a fun thing to do. Do you mean like what we just did here? This, it wouldn't be a problem. Let's do an actual problem. Yeah. So we've got example 149. So if, it's kind of wavy again, if $4,500 earned $384.32 simple interest from May 9th, 2005 to March 31st, 2006, what rate of interest was earned? Right, so we want to figure out what we know, right? And then figure out which rate formula we want to use, right, to solve for the rate, because it's R we want to solve for. So we want to say, okay, well, we're given the principal amount, right? It's $4,500. Now we're told that the amount of interest is $384.32, right? So I must be $384.32. Date 1 is May 9th, 2005. And date 2 is March 31st, 2006. And we want to find R. We can use either of these formulas, right? We can use I equals PRT, or the future value is P times 1 plus RT to solve for R. How can we use the future value if we don't know the future value? The future value is the principal amount plus the amount of interest, right? Since the future value is P plus I, right? That seems like more work than we are willing to do though, right? So I'm just gonna use the I equals PRT. It's easier to solve for R. If we know the amount of interest, right? It's an easier formula to use because it's all being multiplied. So, oops. First, what do we need to do? First, find T. Right? How long was this investment sitting there for? So date 1 in month dot day year. May is 05 and then 09, 05. And date 2, March 03, 3106. Careful there. Yeah, it's just how the computer, or how the calculator takes it. It just won't do it. You can try it, but it won't recognize it as anything. Yeah, so if you did 05.09.05, enter, I think it just ignored it. Hang on. 05.09.05. It just ignores my second decimal. So that's nice. enter. Guess it's a little flexible. Okay, and then we want to calculate our days between dates. So I put a star by it. So date 1 is 0509-2005. I already entered that one. Date 2 now is 03.3106. Enter. Scroll down, compute. I get 326 days. So T must be 326. Oops. 326 out of 365. Okay. So using I equals PRT, I think we can all agree that that's the easier one, right, to use in this case. Right. So I was 384.32. P was 4,500. The rate is what we want to solve for. And T, we just found, is 326 over 365. Bless you. So it doesn't matter how we simplify these, right? Because we're just multiplying and dividing. But I'm just going to say that R is 384.32 divided by 4,500 times 326 divided by 365. I can simplify my denominator. 326 divided by 365 times 4,500. The rate is 384.32 on top, divided by 4,019.178082. And then, so my R is 384.32 divided by, if you want to pull up the previous answer, right, you can hit the second and then the equals has ANS over top, answer. And that's going to recall the most recent answer that I gave you. So I use that quite a bit. Right. So now 384.32 I have on here, and then I go second answer, and it'll show me the most recent answer that it gave me, the 4,019.178082. Right. And then I can hit enter to find 0.095621541. So the rate must be 9.56%. Right, rounding to 2 decimal places for our percentage. Not as a rule, but I am. Do at least 2 decimal places for your percentage. Cool.
So do we need to show the timeline for this?
No, for this one, no. But on the test, right, I'll ask you, or I'll make you include a timeline. So it'll say include a timeline if you have to include a timeline. Okay. Sometimes we don't need it. Same idea, right? Solving for time. We have 2 options, right? From the future value is P times 1 plus RT. Solving for time in general. We're going to divide both sides by P. So we get the future value over P is 1 plus RT. It's going to look very similar to R. Subtract 1 from both sides, we get future value over P minus 1 is RT. Now we're solving for T, so T is the future value over P all minus 1 over R. Or from I equals PRT, if we know the amount of interest, right, this one's going to be easier. If I give you the future value, you're probably better off just using the future value formula, right? So 4,000 grew to 5,000. How long did it take? Right. Then you should use the future value formula. Okay. So I equals PRT, solving for T, we get T is just I divided by PR. Right, so it just depends on what information you have. Questions? Oh. All right, let's do an example. So example 155. Janet borrowed $15,000 from the Bank of Wayne, which is really funny because my parents have neighbors called Janice and Wayne, so it's really close. And once they've had a few, they call themselves Wayne and Jamie. Anyways, so I think this question is pretty funny for that reason and only that reason. So Janet borrowed $15,000 from the Bank of Wayne on November 5th, 2001 for a new necklace. That's important. The Bank of Wayne charges 7.45% simple interest. So interest accumulated amounted to $1,534.67. On what date was the loan repaid? Right. So to find the date that it was repaid, right, we first have to know how long did we keep it out for, right, this loan. Here, we might benefit from a timeline. It doesn't say we have to, but let's do it because we can. Okay. So we start our timeline, right, with our start point and our end point. So we know the initial loan was on November 5th, 2001. And we want to know this date. We know that she borrowed $15,000, and it had time to grow to $15,000 plus $1,534.67. So you could either use the amount of interest, right? That's a nice one to have. Or you can use the future value. The future value then must be $16,034.67. Remember, the future value is just the principal plus the amount of interest. Right? No? You look concerned. Did I do something wrong?
How did you get 1,600?
Oh, that'll do it. Got to keep me on my toes here. What did I do? Oh, that's how my Bank of Wayne works. So we should have what? 16,534.67. That's our future value. Mine looked a lot better. I'd rather pay $1,600 for 15,000. Thank you. I could tell something was up. Okay. So here, we need to find this time. All right. We're also told that the rate, the interest rate, was 0.0745. We can use either of the formulas, right? But again, let's just use the easier formula, right? I equals PRT, because we know we have to solve for T, right? So we need to solve for T. Okay. We could use the future values P times 1 plus RT, right? But I equals PRT is easier since we know I, the amount of interest that is accumulated, is $1,534.67. So I equals PRT. I was $1,534.67. P was 15,000. And the rate is 0.0745. Solving for T. And so 15,000 times 0.0745. I have 1534.67 is 1,117 and 50 pennies times T. So T must be 1534.67 divided by 1,117.50. So T is 1.37330648 years. That doesn't really mean anything, right? Because we need to know on what date was the loan repaid, right? Besides, we can't really grasp 1.37 years. So, need to find the date, right? So we need to use our days between dates on our calculator, which means we need to know how many days is 1.37330648 years, right? So we need to know how many days are in 1.37330648 years. So we can say the days between dates must be 1.37330648 times 365. So I have it in my calculator still, so I'm just going to times it by 365. So I get 501 11.256868 days. Okay. We're always going to round up, right? Because we need to go a little bit over, right? 502 days, because 501 days wouldn't quite cut it, right? So always round up. Always round up for the number of days. So days between dates must be 502. We've seen this before, right? With our profit functions, right? We have to produce not 4.1, but 5 units, right? So we're always going to round up to the whole number. Okay. Now we can use our calculator. Use calculator to find date 2. So we know date 1 in the format month, month, dot, day, day, year, year was November 5th, 2001. November is 11.0501. Date 2 is the one we're trying to solve for, so I'm going to put a star here. And I'm going to force the days between these dates to be 502. Okay. Same idea as before, right? So going into the date function, your first date is 11.0501, enter. Even though there's going to be a date in date 2, you can just ignore it for now, right? And then we're going to go back and compute it. Right? So the days between dates now is the one we're changing. So 502, enter. And then scroll up to the second date and hit compute. It was a Saturday, March 22nd, 2003. A gloomy Saturday. Hey, that's my dad's birthday. Yep. So you entered the first date. Oh, second date, yeah. And then enter your first date, 11.0501. Hit enter. And then scroll past date 2, because we don't know it, down to days between dates. Down. Enter 502, and then enter. And then scroll back up to date 2. I'll just write out here. Saturday, March 22nd, 2003 is what you should be getting.
When we're computing this, do you want us to show it Saturday, March 22nd, 2003, or do you want us to show it?
It doesn't matter. You made it this far. At that point, I'm like, great, moving on. So she paid back the loan on March 22nd, 2003. All right. Any questions about that one? No. Okay. No, maybe let's look at it after then. Yeah. Okay, so next we're going to start talking about equivalent payments, right? And so section 4.6 is on equivalent payments. Equivalent payments are, right? So we've already looked at those, like with D's multiple loans, right? She really only borrowed $5,300, right? But the equivalent of all those on those dates on December 31st was the 5,400, whatever we said, right? So those would be equivalent payments, okay? So now, so equivalent payments are just two payments that enable you to end up at the same dollar amount at a later date. Enable you to end up at the same dollar amount at a later date. So we're going to be talking about payment streams, right? So payment streams are just a series of payments, right? Just like she took out a series of loans, right? And we've got this kind of payment stream going on, right? So payment stream is a series of two or more payments, two or more payments required by a single transaction, or contract. We've already seen payment streams. So focal dates, we're going to talk about the focal date. The focal date is just going to be a date of importance, or the focal date is going to be where we draw our calculations to, right? So for that loan repayment that we looked at for D's loans, right, the focal date, the date that we drew all our calculations to, was December 31st, right? So that's going to be our focal date where we draw our calculations to. And to make the test easier, I've told you, use whatever as the focal date, because sometimes if you're going through practice problems, right, and they don't tell you what to use as the focal date, sometimes it can be hard to figure out. So the focal date is just a date of importance, right, importance to our calculations. Okay. We will draw all our calculations to the focal date. Let's do an example. So example 159. So you go to the bank and they offer you this particular investment. So a particular investment pays $800 payments for 8 and 12 months from now, right? So in 4 months, you get $800. In 8 months, you get another $800. And in 12 months, you get another $800. Right? So what's the most an investor should be willing to pay for this investment today if money earns a rate of return of 6%? So use today as the focal date. Okay? So $800 for 8 and 12 months from now is worth something today, right? It's not going to be worth 800 times 3. It's going to be worth less than that, right? So we should probably map it out on a timeline, right? We've got multiple payments and we've got stuff going on, right? So start with our basic timeline. And we've got today, and then we've got a payment for 8 and 12 months from now, right? So I need 2 more ticks on here, 1, 2. So here's 4 months, 8 months, and 12 months from today. So 4 months, I get $800. 8 months, I get another 800, and 12 months, I get another 800. It says use today as the focal date. You would have anyways, right? Because you want to draw these back to what are they worth today, right? So that's what the focal date just tells you. Okay, draw all these payments back to today. Okay? So remember, I like to start with the one closest to where I want to go, right? So this is our focal date. So this is going to get drawn back to some principal amount. I'll put a subscript 1 on there, right? Because we have 3 principal amounts that we'll have to deal with. Basically the exact same scenario as the loans, right? Except now we're backtracking to a principal amount. So this 800 gets pulled back to another principal amount, and this 800 is another principal amount. The sum of this is the total value of the investment today. Of the investment today. So the idea is you wouldn't pay more for this investment than what it's worth today, right? And that's what they're saying. So on here, we'll just finish off our timeline here. So we've got T here is 4 months, so 4 divided by 12. Nice, no days between dates here. Great. T for this one, we know is 8 months, so 8 out of 12, and T for this one we know is 12 months, 12 out of 12. Yeah. And we'll just jot down that the rate we're told is 6% for all of these. So we can just put it anywhere on our timeline, but it has to be there somewhere. Now, this is your complete timeline. For full marks, you have to have all of this going on. Okay. All right. Let's do this. I can already tell that I have to find P 3 times over. So I'm just going to bite the bullet, solve for P once, and then just use that formula. Right? So we have the future value is P times 1 plus RT. So P must be the future value over 1 plus RT. Now that I've shown that I know that that's how I would find it, right, I can use that formula for P safely. P1, can just plug in the values. The future value, right? The future value is always at the end of the arrow. So on the right-hand side is your future value. On the left-hand side of the arrow is your present value, or your principal amount, as we've been calling it. So your future value is 800 for all of these. Okay. So the future value is 800 over 1 plus the rate is 0.06 times the time for this little guy is 4 out of 12. So it's just the time that's going to change for each of these. So that's nice. Okay. So we do 4 divided by 12 times 0.06 plus 1. So I get 800 divided by 1.02. So this $800 today is worth $784.31. And I can round to 2 decimal places right away, right? Because it's some dollar amount. So if I went to the bank and I put in $784.31 in 4 months at 6%, I could pull it out and have an even 800. Right? So that's the idea. So 800 4 months from now is only worth $784.31 today. Right? So let's find P2. P2 is 800 over 1 plus 0.06 times 8 over 12. Same thing, 8 divided by 12 times 0.06 plus 1. 800 divided by 1.04. Same idea, I can just round to dollar amounts. 769.23. P3 is also going to be worth 800 in the future over 1 plus 0.06 times 12 over 12. That's just 1, right? But I like to be consistent, right? But if you want to just do 1, that's fine. So I can already tell that this is going to be 800 over 1.06. 800 divided by 1.06, 754.72. So the total value is P1 plus P2 plus P3. P1 was 784.31. Plus P2, which is 769.23, plus P3, which was 754.72. So once we add all these up, 784.31 plus 769.23 plus 754.72, I get $2,308.26. So the maximum that we would pay for having $800 4 months, 8 months, 12 months from now, right, should be $2,308.26. So if the bank said, hey, we'll give you this investment if you just give us $2,000, they're desperate. We'll give you $800 4 months from now, $800 8 months from now, $800, right? You're saying, oh, okay, sure, right? And so, but if they said, oh, for only $23.20, you can have this, you can have $800 4 months, 8 months, 12 months from now. You'd say, no, thanks. I'll just invest my $23.0826 and have the exact same thing come out, right? I can go and withdraw $800, then $800, then $800, right? So that's the idea there. So we wouldn't pay more than $2,308.26 today to get $800 4 months, or 4, 8, and 12 months from now. Right, because if it costs more than 23,000 or 2,308.26, then you should just invest that amount and have it grow, and you can just withdraw money if that's a game you like to play. Right? Does that kind of make some sense? Again, tedious, but that's my jam. Yeah. Okay. So just a bit of terminology. I think I said it earlier, right? But when we're pulling things back to the present value, technically that's called discounting, right? We're discounting $800 to today, right? So I'll just throw that in there because I think I used it already. So the discounting is the process of calculating a payment's present value. We ready to kick it up a notch? Okay, okay. How about example 161? Oops, kind of cut it off. Let's kick it up a notch here. Seems reasonable enough. Tiny little blurb. Okay. Calculate the fair market value of the scheduled payments 60 days from now if money can earn 8.5%. So the payments are going to be $1,000 today, $1,500 in 70 days, and $2,000 in 210 days. So we're dealing with today, right? 70 days and 210 days. But we also want to know, calculate the fair market value at 60 days. Right? So we'll throw 60 days in there. So here we'll definitely need a timeline to keep these things straight. Right? So we've got 4 dates that have come up. So we draw our initial top timeline here. So we've got today, and then we have 1, 2, 3 more ticks. Right? So we've dealt with today, and then there's, we want to talk about 60 days from now, right? So that's the first one that comes up. So here we have 60 days. Next one is 70 days. And the last one is 210 days from today. So let's put these payment amounts on here. All right, so we have payments of $1,000 today, $1,500 in 70 days, and $2,000 in 210 days. So far, so good. Right? The only thing that we haven't seen before, right, is we want to find the fair market value at 60 days. There's no payment at 60 days, but there's nothing that says that we can't just draw all of these payments to 60 days, right? Making 60 days our focal date. Right, so on the test, it would say use 60 days as the focal date. Right, so you don't have to flounder trying to figure out where your focal date is. Right, your focal date is where you're going to draw all these calculations to. Right, so that $1,000 today, that's going to get pulled forward to some future value. Right, but then the 70 days and the 210 days, those are going to get pulled back, right, discounted to some present value or some principal amount. Right? And then you add those up to find the total value at 60 days. Right? That's the fair market value. Okay. So, all right, here we go. This arrow from 1,000 is going to go forward to 60 days. Okay. Now I'm going to use subscripts to denote the order that I'm going to calculate these in, right? So even though there's only one future value, I'll still call it future value 1, right? To indicate that that's the one I'm going to find first. And then I'll find present value or the principal amount 2 second. So the 1,500 is going to get discounted, right? Pulled back to 60 days. To some P2. And then same thing, this 2,000 is going to get discounted to some P3. The sum of all these is going to be the fair market value at 60 days. Fair market value at 60 days. Our timeline isn't quite complete. We need the rate. So the rate, I'm just going to put it off to the side here because it's the same for all of these, is 0.085. But we also need T for all of these arrows. Right? And then we'll be finished our beautiful timeline. The length from today to 60 days, I just know is 60 days, right? So T must be 60 over 365. Here's where we want to be careful though, right? The distance between 60 days and 70 days, that's only 10 days, right? So you don't want to use the 70, right? And that's where we have to be careful. We don't want to use the 70 and 210 because we want to talk about from 60 days now. So that's a little sneaky. But here, T is 10 out of 365. And then don't be a hero, use your calculator. 210 minus 60. T is 150 over 365. Phew, what a beautiful timeline. This is everything you need. Nothing that you don't. It's all mandatory. Okay. All right. Well, I know what I have to do. Calculate the future value, the principal, and the principal. Okay. All right. Made it this far. Future value is P times 1 plus RT. Future value 1, the principal amount is 1,000 times 1 plus R, which is going to be 0.085 for all of these. And T is 60 over 365. So these calculations we've seen before, and they're becoming very familiar very quickly. Right, that's good. 60 divided by 365 times 0.085 plus 1. Jot it down here, 1,000 times 1.013972603 times 1,000 is 1,013.97. Okay. Moving on, P2, or rather, I'll say future value is P2 times 1 plus RT. Just to show that I know my way around the formula. Right, the future value for P2 is 1,500. So 1,500 is P2 times 1 plus the rate, which is 0.085, times T, which we decided was 10 over 365. Ten divided by 365 times 0.085 plus 1. 1,500 is P2 times 1.002328767. So P2 must be 1,500 divided by 1.002328767. Doesn't matter how you solve for this, right? We should all get the same answer. P2 is 1,500 divided by that answer. 1,496.51. Right. Doesn't matter which way you slice or dice it. As long as you show your work and you get the same answer, then you did it. How about P3? I'll start again. Future values P3 times 1 plus RT. Why not? 2,000 and the T was 150. 2,000 is P3 times 1 plus 0.085 times, I said it 150, right? Thank you. $150 divided by 365 times 0.085 plus 1. So I have 2,000 is P3 times 1.034931507. 2,000 divided by that. P3 is 2,000 divided by 1.034931507. P3 is $1,932.50 rounding up. Oh. fair market value at 60 days, we said was future value 1 plus present value 2 plus, sorry, we're calling it principal still. We'll start calling it present value soon. Kind of scooting the equal sign over. Future value 1 was 1,013.97 plus P2, which was 1,496.51. It's 1,932.50. And 13.97 plus 1,496.51 plus 19. Oops. I mucked it up. 1013.97. It's 1496.51 plus 1932.5. $5,940 and 49 cents. Nice work. So just a little note here. No. What is 2? 1496, 1932. I was gonna say, how about 4442.98? Martha Stewarting here. Or I just pull it out of the oven. It's all ready to go. No room for error. How about that? Just operator error.
So do we need to show all the steps like this, or can we combine it on the test?
I want to see it broken up. Yeah. So from now on, right, we will use subscripts to denote the order of our calculations. Sometimes it doesn't matter in this case, right? It doesn't matter if we calculated the future value first or last, right? Because we're just adding them up together. But there will come a point where it will matter which one we find first, right? Because we'll use that later on. So to denote the order of our calculations, so we have the FB1, P2, P3, right? Those are subscripts. 1, 2, 3. I know, I'm trying to stick to, but they're all over the map, and I'm trying not to. But for our formula sheet, we use P, the principal amount, but it is gonna be the same as PV, the present value. And that's why I keep slipping up and calling it the present value. But they're gonna be the same. I'm trying to keep it nice and simple for simple interest, but it's tough. So, great. How about another example? 163. Okay. A wordy little bugger. Okay. 4 months ago, Teresa borrowed $1,000 from Josh and agreed to repay the loan in 2 payments to be made 5 and 10 months after the date of the agreement. Okay, fine. Each payment is to consist of $500 of principal and interest at the rate of 9% on that 500 from the date of the agreement. Okay. Today, Teresa is asking Josh to accept a single payment 3 months from now to settle the debt. So what payment should Josh require if money can now earn 7%? Oh boy. Okay. We can handle it. Okay. So 4 months ago from today, right? So we're talking about 4 months ago, but then that also means that we have to have today on there, right, to indicate where 4 months ago was. Okay. Right, just listing all the dates that are given here. And so she was going to repay the loan in 5 and 10 months 4 months ago. Okay. So we've got 5 and 10 months. And then today, right, 4 months after the agreement date, she's asking Josh to accept a single payment 3 months from now. So we've got 5 dates that we need to draw out on here. All right. Start by figuring out all the dates that are in the question. Right? How many are there? Make that many ticks on your timeline. That's going to be a good start. Yeah? Because there's 4 months ago from today, right? So today is also a date. So that's the tricky one. Okay. So then we have to have 5 ticks on here. Can just kind of, need a little bit more room. 1, 2, 3, 4, 5. I'd just like to have them approximately evenly spaced, more for room than for anything else, right? I don't want these to actually be close together if it's only 10 days. I want to be able to visualize stuff. Okay, so let's start by putting today on here, right? So 4 months ago, okay. And so we have to kind of read ahead and say, okay, so 4 months ago, we can start there. So 4 months ago. And then she was going to make payments 5 and 10 months after this agreement date. Right? So here, I'll just put high above the 3rd tick, right? 5 months from agreement. And then 10 months from agreement. I don't quite know which tick that would be yet, because I have to figure out how those relate to today, right? Because then she wants to make a single payment 3 months from today. Right? Okay. So if we rewrite this, right, so we have today, 5 months from 4 months ago is only 1 month from today, right? So let's put all these in relation to today, just because it's easier to think about, right? So this is just 1 month from today. I suspect that 10 months from agreement, right, might be the last one. Okay. So 10 months from the agreement date, that was 4 months ago, that's 6 months from today, right? But she wants to pay it off 3 months from today, right? So I have to bump that 10 months from the agreement over to the last tick, right? Because we had to figure out where the 3 months from today goes. So sometimes we have to kind of move stuff over. So I'm just gonna move it over here. 10 months from agreement. which is 6 months from today. And she wants to repay everything 3 months from today. So that's tricky, but we're feeling good. Feel like we've got a handle on this. Right? If we reread it, we could say, okay, 4 months ago, she borrowed $1,000. Then she was going to repay it 5 and 10 months from now. Right? But then today she decides, hey, I'm just going to make you one payment 3 months from now. Right? So we just needed to bring these dates down to a similar scale, right? And it's just easier to think of everything in relation to today. Right? So what do we have here? Okay. So we want to know how much does she have to pay 3 months from today, right? To make up for one payment a month from today and a payment 6 months from today. So because we're interested in the value at 3 months from today, it doesn't say that's the focal date, right? But because that's the one that we're interested in, we want to find the value at 3 months from today. That's our focal date. Okay. So here I'm going to say focal date. Okay. So it's not always necessarily today. That's the focal date. Okay. All right. So she borrowed $1,000. Okay. And so she was gonna, so each payment is to consist of $500 of principal and interest at the rate of 9% from the date of the agreement. Okay. So we can break up our $1,000, right, because they're being repaid. So she got $500 and $500, right, $1,000 4 months ago, right? But those $500 are being repaid at different times, right? 3 months from today and 6 months from today. Right? So that's why we split up that 1,000 to 500 and 500. Right? And so we can say, okay, well, that's going to be 500 here and 500 here for a total of 1,000 borrowed. Right? And then we said, okay, here, this little guy, this first 500 is going to get repaid, was supposed to be repaid 1 month from today. So this would be some future value 1. Right? So she's supposed to repay future value 1. Okay. Same idea. This next 500 was supposed to be paid back 6 months from today. So here, this little guy is going to be some future value 2. Okay. We'll jot down how long these arrows are, right? T for this first one, we can say is 5 months. T for the second one must be 10 months. And this is the first time that we're seeing this, right? But the rate changes. So for these two, the rate was 9%. Right? But then when they're restructuring the loan, right, the rates change to 7%, right? So for these two arrows, these initial loans, right, the rate is 0.09. And the rate is 0.09. Okay. So now she's saying, scrap that, right? I want to repay these 3 months from today. So what we're going to do is we're going to pull these future value 1 and future value 2 to the focal date 3 months from today. Sneaky. All right. So what we're going to do is we're going to say, okay, well, this amount is going to get pulled forward again. So it's going to become another future value, right? So some future value 3. This is where it's going to be important, right, that we keep those subscripts to denote the order that we have to calculate these things in, right? Because we can't find this future value without knowing that first future value, right? Same thing, so the future value 2 has to get pulled back to some principal amount 3 months from today. Right? So this little guy is going to get pulled back to some P4. And the total here is going to be the total owing 3 months from now. Total owing 3 months from now. So these arrows, right, are each going to be worth some time. The time between 1 month from today and 3 months from today is just 2 months. Right? So T for this little guy is 2/12. And the rate has changed now to 7%. So we have to keep track of that too. How about this last arrow? Nice. So the time between 3 and 6 months is 3 months. And the rate again, is 0.07 for this. Phew. Our timeline. It's beautiful. No, it's a train wreck. I don't know. Can't decide. Okay, but in making our timeline, right, we've already identified what we need to solve for. Right, we're going to solve for that first future value, that second future value, then we're going to pull them back to find the equivalent payment 3 months from today. So, nothing to it but to do it. Future value 1 is P times 1 plus RT. The principal amount was 500. Oops. Times 1 plus R, which is 0.09 for this one, times T, which is 5/12. Five over 12 times 0.09 plus 1. 500 times 1.0375. 518.75. Okay. Mm-hmm. Yeah. It would start from that future value. Yeah. Because she agreed to pay 9% to 1 month from today. Right. And then he says, well, I'll give you a deal. If you're paying early, then I'll make it 7%. Okay. Good though. So the future value, 518.75. How about the second future value? Future value 2, P times 1 plus RT. P is still 500 times 1 plus R, which is still 0.09 for this one. And T was 10 over 12. 10 divided by 12 times 0.09 plus 1. 500 times 1.075. 537.50. So this is the original payment plan, right? She says, oh, I'll just borrow $1,000 from you today. And in 5 months, I'm going to give you $518.75. And in 10 months, I'm going to give you $537.50 to pay back. Right? So that's the original payment plan. That's what they agreed to. And then now she says, today, she says, oh, well, scrap those, right? I'm still going to pay you back an equivalent amount just 3 months from now. Right? So now we need to figure out, okay, so for future value 3, right, future value 1 becomes the principal amount, right? Because she has to borrow that amount again for a little bit longer, right? For another 3 months, because she's not paying it back. So she has to borrow it again, right, at this new rate of 7%. Okay, so to find future value 3, we need to use future value 1 as the principal amount, right? She had to borrow it again, is kind of how I think about it. Right, so she was supposed to pay that off. She's saying, no, I'm not going to pay that back quite yet. Right, I'm going to borrow it again, but now that's your principal amount. Okay, so future value 3 is P times 1 plus RT, where P is actually future value 1. So I'm going to show that in my work here. Future value 1 times 1 plus RT. Future value 1 was 518.75. Times 1 plus the rates changed to 7%. 0.07 times, and she's only borrowing it for 2 months, so 2 out of 12. So 0.07 times 2 divided by 12 plus 1. Oh. I'll jot down 518.75 times 1.01166 repeating times 518.75. 524.80. So now we can find this last present value, or the principal amount, right? Because she's not paying it back 6 months from today. She's paying it back earlier, right? So we can discount it back to 3 months from today. So for P4, our future value is future value 2. For P4, we use the future value as future value 2. So future value 2 is P4 times 1 plus RT. We know future value 2 is 537.50. Is P4, which we're trying to find, times 1 plus the rate is 0.07 now. And T, we said, was 3 out of 12. Three out of 12 times 0.07 plus 1. P4 times 1.0175. So P4 must be 537.40 divided by 1.0175. P4 must be 528.16. Oh, thank you. Sure is. No harm, no foul here. So then this must be wrong too. So 537.50 divided by 1.0175. How about 528.26? Better? Okay. So instead of paying back, right, in 5 and 10 months from the agreement date, she's saying from today, I'll just pay you back one lump sum, right? So the equivalent payment 3 months from today is going to be future value 3 plus present value 4, principal 4. Future value 3, 524.80 plus 528.26. 524.80 plus 528.26. 1,053.06. So that's what she would have to pay 3 months from today, right? And that would be equivalent to payments at 5 and 10 months from the agreement dates. Okay. We'll end it there for today. That was a lot of work. So make sure you practice those, right? We'll do another couple of examples next day, but that's good for now.